says we have a triangle in quadrant 1. That is our favorite quadrant to be in. Because what do I not need to worry about if I'm in quadrant 1? Negatives. Those negatives can be killers, guys. It's so easy to forget. But in quadrant 1, I don't need to worry about it. And I have a point where x is 4 and y is 5. Remember, when you plot a point, this is x and this is y. So it says 4, 5. So what's missing then? What's missing? The hypotenuse. So how will I find the hypotenuse? Pythagorean theorem, right? Just like you did on your quiz. Just like we always do when we have two sides given. We can always find the third one. All right, so here we go. A squared plus b squared equals c squared, right? The hypotenuse is always c. So what is that, 41? So it looks like c is the square root of 41. And our job is to find all the functions, so we have to find sine, cosine, and tangent. And then cosecant, secant, and cotangent. All right, so remember angle theta here, that's how you determine what's opposite and adjacent. So sine would be 5 over root 41. By the way, on your quiz, did you have a radical? No. Wasn't Mrs. Ford nice? She gave you nice numbers.
That confused me more.
But I can't win. So if you have a radical on the bottom, it can't be there, so we'll multiply top and bottom by root 41. So there we go. Cosine, 4 over root 41. 4 root 41 over 41. And tangent, 5 over 4. Now, does anybody have a question about those three? Because these are just going to be the flips of those, right? All right, so here we go. Let's start flipping. So this will be root 41 over 5, root 41 over 4, and 4 over 5. And again, like we said earlier, no negatives in this problem because the point that I was given, 4, 5, is in quadrant 1. Okay, now, part 2 is exactly the same, except I didn't draw a picture. Everything is the same. I gave you a point, just like this one was 4, 5. I gave you the point 2, -2, and then you had to find all this stuff. Okay, same thing. So where is 2, -2? I'm on 2a. I'm going to do exactly the same thing I just did, only my point is 2, -2. Where is it?
Quadrant 2.
2, -2. Wouldn't it be in quadrant 4?
Oh, yeah.
Positive 2, -2. That's what you meant. Okay?
Wait, how does it count? Doesn't it go 1, 2?
This is 1, 2, 3, and 4. Okay? Now, for purposes of this problem, you do not need to know that. You just need to get it in the right spot. You got to have it down here. Okay, so now we have a 2, and a positive 2 and a -2, right? Because it's given in the point. And we're right back to where we were a minute ago. We need our hypotenuse. But when we do the Pythagorean theorem, please do not include the negatives. Because you are squaring, right? So there's no point in putting the negatives in. It's just going to mess you up potentially. So it's just 4 plus 4. So c squared equals 8. Now something's going to happen in this problem that hasn't happened to us before. It's no big deal. We're not going to panic. The square root of 8 actually reduces to 2 root 2, right? So c equals the square root of 8, but I always reduce everything, so it's 2 root 2. For the hypotenuse. Right? So now I'll start filling in the blanks. So sine will be opposite over hypotenuse. Opposite over hypotenuse. Now, do you see that 2 up there and that 2 down there? They're both not in a radical, so they actually...
She can't see behind.
Let's turn this way to give you a little more room. How's that? So these are going to cancel. So I'm going to have -1 over root 2 because the 2's cancel like normal. But then I have a radical in the bottom, so I'm going to have to multiply by root 2, so I'm going to have -√2 over 2 as my final answer.
Space.
I know, there's not much room for that. When you flip it, I would flip this version right here. I think that's going to be the easiest one to flip. If you flip it here, it's okay, but then you'll have to reduce again. If you flip it here, you'll have a radical in the bottom, so I would not do that one. But I think I'll flip it right here. So this is going to be -√2 over 1 or -√2 for my cosecant.
Wait, I'm confused. So you had a 1 up there, but then you switched to a 2 on the bottom.
Okay, I cancel these 2's out. That left a 1 up there. Then I rationalize by multiplying top and bottom by root 2. That's how I get rid of the radical. So that's how the root 2 got up there, and a plain 2 got in the bottom, because root 2 times root 2 is 2. That's what we've been doing in all of our problems that had radicals in the bottom. The only thing different about this one is we have this canceling at the beginning. And same thing's going to happen with cosine, because when we put adjacent over hypotenuse, we're going to have exactly the same fraction, only positive. So I'll cancel out the 2's, and that's going to be 1 over root 2. And then I'll multiply the top and the bottom by root 2, and get root 2 over 2 as my final answer for the cosine. Then I'll flip that one, get root 2 over 1, or just root 2 for the secant. Flip this. Tangent's going to reduce also, because tangent is opposite over adjacent. So that's just going to be -1 over 1, if you want to write it that way. And the cotangent is just going to be the reciprocal of that, so it is also going to be -1. Okay. That was, you had to do that simplifying at the beginning. That was a little bit tricky.
Can you leave it as 2 over -2?
No, you want to make it,
Reduce
yeah.
it.
Yeah. We always reduce. Okay, let's look at the next one. This point is -1, 4. So this point is actually in quadrant 2. X is negative, Y is positive. Theta, as always, is at the origin. Now, who knows what the first step has to be? Pythagorean theorem. So we're looking for our hypotenuse. So we'll say 4 squared plus 1 squared equals c squared. Our hypotenuse is always c, always the one that's over here. So it looks like 16 plus 1. Did you get root 17? So now we fill in our stuff. This, other than the negatives, this is exactly what you did on your quiz. Because now you got to do sine. So sine will be opposite. This is the opposite. So 4 over root 17, which is 4 root 17 over 17, right? Because you're going to multiply top and bottom by the square root of 17. The cosine will be adjacent, so negative 1 over root 17. And if you leave a 1 there, that's fine. Negative 1 root 17 or just negative root 17. Doesn't matter. And tangent, you can leave it as 4 over negative 1, or you can write it just as a plain negative 4. Now, does anybody have a question about those three? Where they came from? Any of those numbers? Because you know, we're now going to just flip them. So cosecant, root 17 over 4. Cosine, root 17 over negative 1, or just negative root 17. Either one of those is fine, whatever you prefer. And negative 1/4 for the cotangent. Now, are we okay with that? Do you see how it's exactly what we've done before? The only difference is we've got negatives now because our points are in different places. But the process is exactly the same. Okay, so for the next problem, the process is going to change. Tell me what is different about this next problem.
There's no triangle.
What?
There's no triangle.
Okay. There's no triangle, because when you plot the point, when you go, like the last one, we went, what, negative 1/4? So we made a triangle just by going left 1 and up 4. Well, this time, we're going down negative 2. That's it. There's no triangle there. Remember, any triangle you draw, and think about all the examples that we've done the last couple of days. If it's in quadrant 1, it looks like that. If it's in quadrant 2, it looks like that. We just had one of those. We haven't had a quadrant 3 today, but we had one yesterday, and we had a quadrant 4. It looks like that. That's how the triangles look. It's called the butterfly bow tie. If you're going to draw a triangle in trigonometry, that's what you draw, one of those. You can't butterfly bow tie a point that's right here. So instead of butterfly bow tie, instead of a triangle, we draw a circle through that point. So go ahead and draw a circle through that point. And since I drew it through that point, I know my radius. What is my radius?
2.
2. Since I have a point, I know that x is 0 and y is negative 2. Now remember, it was impossible to draw a triangle, so that's why I drew a circle. Now look at your pink sheet. So far, every time we've done a sine, we have used opposite over hypotenuse, right? And that's perfect if I have a triangle. But isn't there another definition listed there? If you can't draw a triangle, then you need the other definition of sine. And what is the other definition of sine? Y over R. So we have a y and we have an r. So we'll just put y over r. So negative 2 over 2, which I can reduce to just negative 1. Now what's cosine? X over r, so that will be 0 over 2, or 0.
Y over X.
Tangent is y, what's wrong with y over X? There's a 0 in the bottom, and what do we know about zeros in the bottom? Undefined. So there is no tangent for that angle. In a few days we'll be graphing these functions and you'll see asymptotes in the tangent because it's undefined sometimes. Okay, now we're just going to flip them over. So here we go. We'll just flip them.
Negative 2.
So this is going to be 2 over negative 2, which is negative 1 again, right? This one, you're right, is going to be undefined because when you flip it, it becomes 2 over 0.
Why is it 0 on that symbol? Like, why is 0 over 2?
Because it was on top, it's already.
Nothing divided by 2 is nothing.
Isn't it like okay?
Yeah, it's like, Claire, if it's 0, it's okay. Then on the bottom, it's NO. Think it like that.
Hollis always used to scream at everybody that you can't sit on the egg. So if you're sitting on the 0, it's going to smash. You can't do that. Now look though, our tangent was undefined, but when we flip it, then it becomes okay. So these are the final answers right here. All right. What about the next one? What do you think about it? Is it going to be the same thing?
Yeah.
Because the point, if you physically plot the point 3, 0, you come over 3 and stop. Right? So I'm going to draw a circle through that point. That's the point 3, 0. So I know x is 3, y is 0. And what would the radius of that circle be? 3? Look at it. If it goes through that point, and the center's at the origin. I didn't mention that, but yeah, you always have your center at the origin. Then wouldn't that radius have to be 3 to go through that point? So now we can start filling stuff in. So look at your definitions. Sine is y over r. So that'll be 0 over 3 or 0. Cosine is x over r, so we get 3 over 3, which is 1. And tangent is y over x, or 0. So now we start flipping, so we get, for cosecant, we get 3 over 0, so that's an undefined. For secant, we get 3 over 3, so that's 1 again.
Yeah.
And for cotangent, we get 3 over 0, so we get another undefined. How do we know when we have to draw a circle? Where is the point? Where does the point land if we have to draw a circle?
On the x-axis.
On an axis. Not just the x-axis, on either axis, right? So if you plot your point and it is on an axis, you have to draw the circle. If the point's out here somewhere, we can draw a triangle, right? But if it's on an axis, the point that you have, you're going to have to draw the circle. And actually, those are usually easier to do than the other ones. You don't have to do the Pythagorean theorem and all that stuff. Okay, now, before I erase all this and we move on to the next section, I need you to make a connection for me that's going to really help in this next section. Sine is y over r, and cosine is x over r. That's really the two biggies that you have to remember. Well, and tangent is y over x. Notice that sine is associated with y. So when y is positive, sine will be positive. When y is negative, sine will be negative. And the same thing is true of cosine, only it's associated with x. So if somebody says to me, Lisa, when is the cosine positive? I immediately think, when is x positive? Because cosine goes with x. Tangent is a little tougher because it actually goes with both. So if y and x are both negative, let's say, if y and x are both negative, then the tangent would be positive because it's a combination of those two. So when I look at the next section, it says, tell the sine of the sine, cosine, and tangent of an angle in the given interval. All right. There is a lot to remember, guys, and I'm about to give you some more. When we talk about directions, which we've done a lot, we use our compass, straight up is 0, right? We talked about that. That setup only works on a compass, and we only use a compass when we're doing directions, okay? So if somebody says you got an airplane flying, or you're going south, southeast, or something, then you're going to use your compass. But otherwise, if you're doing pure mathematics, just regular mathematics, you use a different setup. You don't use a compass. When I'm in a classroom, I'm not using a compass when I talk about my angles. The setup in regular math, the setup for everything except the compass, every problem except a compass, directions, the setup is this. Okay? So we go this way. We start right here on the positive x-axis. That's considered to be 0. And we start going up. So that would be 90, and 180, and 270, and 360. So in this next problem, this is called standard position. These angles are in standard position. In the next problem, it says I am in the interval from pi over 2 to pi. Now, those are radian measures. We know pi is what? 180. And that means pi over 2 would be 90, right? 180 divided by 2. So we're talking about the interval from 90 to 180. So we're talking about this space right here. Would you agree with me? what can you tell me about any point up here? Will x be positive or negative in this space right here? Negative. And y will be positive. So if I am talking about this interval from 90 to 180, then I am talking about points that are negative, comma, positive. Like negative 2, comma 3 or something. So that's x and y. Now remember, cosine is associated with x. X in this space is negative. So your cosine is going to be negative because x is. Your sine, on the other hand, is going to be positive because y is. All you're doing here is telling me whether sine, cosine, and tangent are positive or negative. Cosine is negative, sine is positive. Now, what about tangent? Tangent is the trickier one. Tangent is y over x.
Negative.
So if you put y over x, won't you get a negative number?
Mm-hmm.
So tangent will be negative. The SIGN of sine depends on y, and the SIGN of cosine depends on x, and the SIGN of tangent depends on both. All right, let's look at the next one. What interval are we talking about? Pi to 3 pi over 2. Now pi we all know is 180.
270.
So pi is 180 divided by 2 is 90 times 3 is 270. So we're talking about in problem B the interval from 180 to 270. Okay, where is that? Where's 180 to 270? Right here.
Negative.
And we know down here points are negative, negative, right? So x is negative and y is negative there. So if we want to know about the cosine, we look at x. X is negative. If we want to know about the sine, we look at y. Y is negative. And if we want to know about tangent, we put y over x. So negative over negative, that will be a positive. Not too bad, okay? Not too bad. So now we're going to get specific. We're not going to use our calculator, and you're not going to tell me a number. You're just going to say positive or negative, okay? So sine 152,
Negative.
I want to know if that's a positive or a negative number. That's all. So no calculator, just look at it. Where would 152 fall? Now remember, this is 0, and we go this way. So where would 152 fall? Right here?
Positive. Yeah.
So here, my points are negative, positive, right? Negative x, positive y. I'm looking at sine, and sine is y. So the answer is positive. Did you follow that thought process?
Yeah.
All right, let's try the next one. Cosine 8 pi over 9. All right, you want to change that into degrees? Would that be easier for you? You know how to change it to degrees. Pi is 180.
160.
Divided by 9 times 8, she says that's 160. Now that isn't the answer to the question, but now maybe you can figure out where 160 is. Isn't it in the same quadrant? Only this time we want cosine, and in that quadrant, cosine is negative. Try the next one on your own. Tan 300. Figure out, now remember, this is your setup. You're starting here and going this way. Figure out where you're going to put 300. And then remember, tangent is y over x. So you should be able to tell whether it's positive or negative. Which quadrant did you put 300 in? Down here, I hope?
Yeah.
Yep. And points here are positive, negative. You gotta think about that. Here's the origin. Positive, negative. So we want tangent. Won't that be negative over positive? Which will end up being negative. The tangent of 300 is a negative number. Ooh, 15 pi over 8. You can use your calculator to help you with that one. That's a big thing. Tangent, or excuse me, cosecant. It's cosecant. Cosecant 15 pi over 8. How many degrees is 15 pi over 8? What? 337.5. Anybody in agreement with that? Is that okay with everybody? Okay. No, we're not doing 1 over anything. We're changing this into degrees so that we know where to look for it. So pi is 180, divided by 8 times 15 should be 337.5. Okay, now where is this angle? 337.5. Where is it? Here? Here? So here are my points. This is what my points look like, my x and my y. Now, cosecant is the reciprocal of what? Sine. Sine is y, so I look at y. So the y is negative, so the cosecant of 337.5 is negative. This is so easy, but there is so much to keep track of. Okay, now look at the next one. Cosine negative 200 degrees. Anybody have an idea how I handle negative 200? Instead of going up and around, I go down and around. Negative angles, you still start in the same place, but instead of going up and around, you go down. So I need negative 200. So think about it. Remember, every quadrant is 90, right? Every block here is 90. So if I'm going 200, tell me where to stop.
Right there.
Right there. Negative 200 is going to be up here, right?
Yeah.
Because this is 180. I got to go a little bit past, a little bit more. So I'm in quadrant 2. I'm doing cosine. Cosine is x, so the answer is negative. I have no idea what pi over 11 is. No idea. 16 something? Yeah. Okay, well I'm not even going to talk about this one too much because where's 16? Quadrant 1? And what do I know about everything in quadrant 1? Positive, right. If you're in quadrant 1, there's no conversation to be had because everything's positive, right? So if you have an angle between 0 and 90, you're positive. Oh man, cotangent 500. What's that? 500? What does that mean? Does that mean I have to go more than once around?
Yes.
Because once around is 360. So I'm going more than 360? How much more than 360 am I going?
140.
140? So remember, the 360 is just going to bring me back to where I started. So I can pretty much forget about it. But that extra 140 is important and puts me in quadrant 2.
Yeah.
And if I'm in quadrant 2, I already know my points look like this. And I am doing a cotangent.
Negative.
You're right, because you're exactly right. Good job. Cotangent is reciprocal of tangent. Tangent was y over x, so this would be x over y. Tangent is a combination of both of them, right? Super. Last one. Secant negative pi over 7. I don't know, how many degrees is that? Negative what? 25? 0.7? About, I don't need it exactly. I just don't know where it's at. So negative 25 will be here. And my points are positive, negative here.
Positive.
Right? I want the secant, which is the reciprocal of the cosine, which is x. So it's going to be positive. Because x is positive, so its reciprocal will be positive. Right? Secant is also x. What? I come down because it's negative. Normally I go up. So I come down because it's negative. In standard position, up is positive, down is negative.
Is it positive because there's a negative?
No, it's positive because x is positive.
Oh.
X is positive and secant is cosine, which is x.
Yeah.
Okay? Okay, well, we're all packing up like you think it's time to go. It is. I'll make a note of this. That's a good stopping point. Oh yeah, that's a really good stopping point. Okay.